Hello everyone, in this video we will learn how to do linear regression using package called Rattle. So to do this, first we need to download all these packages. So I will leave this code down in the description. This package Rattle, actually it uses a lot of other packages to give you multiple type of analysis. I should mention that this package uses this package for data mining, data science and machine learning. So I should give you a simple presentation about this package. So the package was created by Graham G. Williams for data mining. It uses a genome graphical user interface. With this package, I will leave this paper. So to install this package, just copy all this code and pass it in RStudio or R. So this is the interface of package Rattle. This package can be used for data mining and give you a lot of options, like using machine learning algorithms. So what can this package do? It give you a lot of type of analysis. For example, you can explore data. For example, summary, statistical analysis, distribution analysis. And also you can do all kinds of tests like student test, Fisher and other correlation tests. You can also transform the data to suit the modeling. For example, you can code or recode the data, and also you can build models. For example, linear regression, multiple regression, logistic regression, and you can evaluate all these models using training data, using validating data, and you can also review the log. Log, it means all the code that you've used in your analysis. You can copy and paste all this code of the data mining process. So now we will go to install these packages. So to install these packages, just copy and paste all these codes. The first code, install package Rattle, and dependence. Dependence means all the other packages that need the Rattle to work. For example, Rattle gives you the possibility to plot all kinds of graphical or do the graphical analysis. So it needs in this process it needs ggplots too. So this command or this line it install all the other packages, for example ggplots too or the other. This package rgtk2, it's give you the possibility to have the interface, Rattle interface. We will explain. This is the Rattle interface. This is the Rattle interface. This package rgtk2 give you this interface. The R part is part of this package Rattle, part 2, for plotting the graphs. So this line, sometimes this interface can show up in other language, for example German or French, or so if you like this interface in English, just type this command: system set environment language English. This is English. If you like this interface in French, just write this FR. Or if you like other language, for example German, or just look for the code of your country. Now we load the library. The first library is airpart, second one is airpart plot, and library rgtk2, and the library Rattle. After loading these packages, just click in Ctrl plus Enter or run this code. Third package is rgtk2. Now this package Rattle, and now when I run this code, the interface will pop up here. So this is the interface of the Rattle R data mining package Rattle. So I should explain or gives a review of all this part of the Rattle. The first thing is this part is data. For example, if you have data, for example, if you have R data file, you click here and you choose your R data. For example, this example, R data. And if you want to use the library of this package Rattle, just click here. For example, if you want just to test this package and simulate this package, I should mention this that this package it took me for 45 minutes to download all the package. So the time it depends on your internet speed, on your connection speed. So if you have a good internet speed, just this will take you 30 minutes or more or less. And if you have slow internet, just can be go to until 2 hours or 1 hour. It depends. As I said, if you have R data file, just click in this option. And if you want to use the library of this package, just click in the library and wait. And you can choose whatever you want of this library. For example, we have here air passenger data, air pass data, Mustang data, just choose one of this data and start to simulate your model. If you want to use your own data, just go to this, choose this option, and browse from this button. So I will go directly to my data. So go my data here, demos, and you should change this option to all files. For example, the package accept CSV file, text file, Excel file, and other type of file if it's possible. So I will do my simulation by this data. It's Excel file data for simulation. Open. After choosing the data, you should directly execute this command. It's very important to execute this command. This is my data. It's a big data. All this this variable that I have in my data, all this variable. I should show you the data. This is the data that I'm using in this video. It's a big data analysis. So this is my this is my variables. All these are variables. For example, I have this zy variable. Before, if you want to do a simple regression, so this video is for simple regression. I should do this. I should ignore all this variable. So I will start by ignoring all variables. And after that, I will choose only 2 variables for this analysis. The package can handle all these variables and give you the result, but for just to sample this analysis, I will choose only 2 variables and trying to interpret and show you all the necessary process to have the result. And so just clicking in ignore all these variables. So now I will choose my own variables. For example, I want this variable. I want this variable to. For example, I want to verify an hypothesis. For example, does this variable zy impact this variable tx? Target is mean dependent variable, and this zy, it's independent variable. So our model will be like this: tx equal z zy plus the error. So we are using simple model, so simple regression. So we have two variables. Now moving to explore. After I choose the dependent and independent variable, I should click in execute. Always click in execute when you finish your variable or choosing your variable. Now I will move to explore our data. I will start our data by summary, statistical analysis. So I choose here summary and execute. So this is my statistical analysis. We have here two variables. This is two variables. The first variable is zy and tx. For the simple distribution table below, the first and third quantile refer to the first and third quartile. So we have here the minimum of the zy, the first quartile, the median, the mean, c'est la moyenne, the third quartile, the maximum for the variable zy and also for tx. If you want to add other type of analysis, for example, describe basics, the kurtosis, skewness for the aplatissement and normality test, show missing, cross table. So this is my description of the data sets. For the variable zy, we have zero missing value. So yeah, we don't have missing value in the zy. We have the mean, GMD, and all type of quartile. Also the analysis for tx, and we have the frequency, proportion. For the basic statistics for each numeric variable of the data sets, we have the minimum, maximum, quartile, third quartile, mean, median, the sum, the mean, the variance, standard deviation, skewness, kurtosis, and also for variable tx. So I will not interpret this variable or saying that will take us a lot of time. So it's simple analysis, so no need to interpret this. So the kurtosis, it's give you a little definition, a small definition. For example, kurtosis for sharper peaks and flatter tail, l'aplatissement est. This is the skewness, the missing value, no need for nice status, it's completely observed. So move on now to the distributions. For the distributions, we can have this box plot graph and the histogram. So I will analyze these two variables, the xy and the vx, in function of, for example, gender. So in the output, we will have the data in function of the male and female and all, and So I will choose here gender and click execute. For the first I will choose my variables before clicking in the execute. So I will look for my variables. I'm using the tx variable, so I want to have the box plot of this variable and the histogram. It depends on your analysis. If you want this cumulative Benford and pairs, so just click in this option. And also I want my other variable, the zy, so I should look for the zy. I should mention that this part of the variable, all this variable in this part are numerical, and this variable are categorical. For example, categorical for gender, we have male, female. Country, we have in this analysis, I think we have five countries. So all your categorical variable are here. This is the, for example, gender, we have 3, we have male, female, and the 2. And the 2, they gather the male and female. And for country, we have 6 countries. Education, we have 4 type of education. Position, we have 6. So this is for categorical variable. So after choosing our variable, and I choose to group my variable in function of gender, so I click in execute. The output of graphical output, you will find the graphical output here in the R. So this is the distribution of the variable tx in function of the gender. So we have 1 and 2, male and female, and the variable zy in function of gender. We have male and female. I should mention that this graph is the histogram, and here we choose the histogram and the box plot. So go to this flash and choose previous plot. So this is the box plot of the variable tx in function of gender. So we have here male, female, and all. And for variable zy. We did our analysis in function of gender. We could choose, for example, in function of country, and click in execute. So the output here is in function of the, we have 5 countries, and this is the output of the variable tx in function of country, and variable zy in function of countries. And this is the box plot. So it depends on your data. Also, you can choose, example, education. Go to R. This is a function of education. For example, if we want to export this this graph for here to, for example, in Word, just click in export. You can copy this to clipboard for this, and copy plot. Click in copy plot and choose to paste it here. This is the output. So after that you can modify this. This is your output. After plotting our variables, we can move on correlation. Here we have only two variables, so no need to not give you sense to plot to have the correlation. For this correlation, you can use this correlation for multiple variables. We will see this after this. And if you are the correlation give you three options, three coefficient of correlation. You have person, candle, and Spearman. You choose whatever you want, and it gives you the output. The output give you the output graphical and table. Give you a table for the correlation. And if you want to do principal component, you choose. So I will move now to the test. For this, I want to do, for example, Fisher test. So I choose my sample. So my variable is zy. I want the Fisher test for this variable. So and click execute. So this is my output test. This is definition of the test and the null hypothesis. So this is the output. Move on now to the. I should go directly to model to estimate our model. This is I'm using. We want to estimate linear regression, so I choose linear regression. After choosing the linear regression, this is numeric, and click execute. This is the output. This is the formula. We have zy in function of tx. We have tx in function of zy. This is the residuals, the mean, the first quantile, median, third, and max. This is the coefficients. We have the intercept. It's highly significant. We have here 3 stars. It means that's significant in order of 0.001. And if it's 2 stars, it means that significant in 0.01. And if it's only 1 stars, it means that significant in 0.05. So as I said, the intercept is highly significant, and also our variable zy, independent variable, is significant. So and we can also, we have here also the R square. It's not high, 0.14, and adjusted R square. We have also F statistics and the p-value. P-value of I think this is DQ for log or. And also we have analysis variance table. This is the variance table, ANOVA. So here we have the output. It's you can say that's the output table. And if you want to have the plot or the graphical analysis, just click in plot and go to R. This is the output. Here we have the residual versus the fitted model. The fitted model, and here scale, location, residual, and leverage. So it depends on your data. This is actually it's easy to analyze all this. Now move now to evaluate our model. So evaluate our model, it means if you want to do a prediction of your model, so just go to this p-value and observation and click in validation and click execute. And you will see the output here. So this is our data and the pseudo R square. The continuous line in blue is linear fit to point, and this line and point is predicted or observed. So if we want also to import this this graph, choose one of these options. After that, if you want to import your all this code, just go to this log and copy this or this line and go to R. Choose R script and paste it here. So this is all what we execute in this Rattle. So it's give you the output. For example, I want to execute this. I want to execute this and this, and this line will show this variable and this plot on this graph. So this is the output. So, and also if you want to see this line and execute this and this. So all these graphs and outputs are here in the log. So you can copy this or this line. Sometimes you will find this definition and interpretation. Now if you want to save this or export this, you can save this all these steps and these configurations. I should mention that I didn't use all the options. For example, we have here cluster for machine learning. You can choose, this is the algorithm key means and EOKIM, hierarchical, big cluster. This is all these algorithms are famous in data analysis. And also this is for example this model, you can use this tree and forest, and also you can do a neural network analysis. It's a powerful package, and we will explain all these options and machine learning algorithms in other occasion or other videos. So I should mention that if you want to save this or these configurations, just go to save and save your configuration. As you see, here's the extension of this folder or this Rattle extension Rattle. and you can rename this, for example, model, regression models, regression model. I want to save it in my desktop, so save. So also you can save this code also here. Click and save, choose OK. If you want to save it in desktop, name this model, regression model, and click and save. I hope this video will help you to start with this package for data mining and data science. So if you like my videos, click and like and subscribe for more video and to see other videos for other type of analysis. So thank you very much.